Hey, this is Miss D, and these are the notes on vectors. So we're going to talk first about what is the difference between a vector and a scalar. This is review, should be review for all of you. So a vector and a scalar. A vector is a measurement with both magnitude, which is the size, and direction. So it's basically a number and a direction. And here's an example. Displacement is a vector, velocity is a vector, acceleration is a vector. So like 5 meters per second squared north, that's a vector. And that's why there's a little arrow there, it shows the direction. A scalar, on the other hand, is a measurement that has only magnitude, so it only has a size. So 5 meters, that is a scalar. And some examples of scalars are speed, mass, time, volume, anything like that. Distance is also a scalar because distance does not have a direction. So let's draw some vectors now. So first off, you need to know that a vector is going to be drawn using an arrow, and the length of the arrow indicates the size of the vector, and then the direction that you draw the arrow shows the direction that the vector is going. So if you wanted to indicate something was going north, you would draw an arrow straight up because that's the direction we indicate north is at. And so that we don't have to do any trigonometry, we're going to break vectors down into two separate components, their x and their y component. What does that mean? That means this. Here's my vector, 5 meters northeast. So rather than going ahead and having to figure out what the angle is for that, all I'm going to do is this. I'm going to draw it into a right triangle. So I went ahead and I made that hypotenuse into a right triangle. I've got the x direction and I've got the y direction. And so if I had this on a graph, I could just go ahead and figure out how long is x and how long is y. And I could do that with a ruler also if I needed to. So we're going to talk a lot about resultant vectors. A resultant vector is simply the result of two or more vectors mixed together. So what the heck does that mean? This is what that means. So if I have a dog that walks 3 meters west and then 4 meters north, what is his displacement? So first I'm going to draw a little picture. I'm going to go 3 meters to the west. There's my compass. 3 meters to the west, and then I'm going to go 4 meters north. So that's the path of the dog. It's really important when you draw these that you always draw the arrows tip to tail, which means that the arrow part of one vector should touch the straight line that doesn't have the arrowhead. So like right there, tip to tail. So that's my 3 meters to the west and then my 4 meters north. So I'm going to go ahead and connect them to make the hypotenuse of the triangle, and that is what I would call a resultant vector. And we need to be able to solve for that. How do we find the resultant vector's magnitude, the size of them? And so let's look at the question. Same question, 3 meters to the west, 4 meters to the north. Again, I've got my arrow. Obviously, it's going to be going northwest because I went west and then I went north, so that's northwest. To find the actual size, you're going to have to remember your Pythagorean theorem from geometry. The Pythagorean theorem said a squared plus b squared equals c squared. And when we talk about that, c squared is always the hypotenuse, the longest leg of the triangle. Doesn't really matter what A is and what B is. So for this case, we're going to make the bottom leg A and the side leg B. C is always the hypotenuse, though. In our example, we're going to have 3 squared plus 4 squared equals c squared. And that's 9 plus 16 equals c squared. And that gives you a total of 25 equals c squared. So C is going to equal 5 meters. And again, it's a vector, so we have to have a direction. So it's 5 meters northwest. And that's the solution for that. Let's look at a couple of examples. On practice A, I have 10 kilometers north and then immediately followed by 5 kilometers to the west. Again, notice that I did the 10 kilometers north right here. I'm going to go ahead tip to tail, right? And then join that to the 5 kilometers to the west. And that means I'm going to have 5 squared plus 10 squared equals r squared or c squared. It's labeled r, so I just went ahead and did it r squared. That's 25 plus 100 equals r squared. R squared equals 125. And r is going to equal 11.2 kilometers northwest. I found that by taking the square root of 125. So you will indeed have to use the square root button on your calculator, or if you're using my script calculator, you'll have to actually draw the square root of 125. On this next one, practice B, I'm going to go 30 kilometers to the west and then 40 kilometers south. So let's look at that. I went 30 kilometers to the west, 40 kilometers south, again tip to tail, right? And my resultant vector r is already drawn for you, so it's going to be 30 squared plus 40 squared equals r squared. That's 900 plus 1600, that's 2500 equals r squared. The square root of 2500 is 50 kilometers, and then you look at it and see what direction we're going, southwest. That's it. If you have any questions, you can go back and rewatch the video, or you can just come ask me.